welcome to my YouTube channel. Here's a brief introduction about myself. I am a BTech graduate and these are the subjects that I teach. So if you would like to connect with me for a one-on-one or a group session, please check out the description given below. So this will be the last video for the chapter of force under the syllabus of ICSE. So let us move on to the next question, which states that a uniform meter rule of weight 10 gram force is pivoted at its zero mark. What does this mean? That if we try to imagine in this particular way, that there is a meter rule, and in case of a meter rule, this particular part is the 0 centimeter mark, and this particular part is the 100 centimeter mark. And according to the question, it is given to us that this whole thing weight is 10 gram force. So now what to do? So in this case, always remember that they are talking about the weight of the meter rule. And in case of the weight which is for the meter rule, we need to understand the concept of which is known as center of gravity. So according to center of gravity, for the meter rule, its particular point where all the algebraic sum will be in equilibrium, that particular point is 50 centimeter. So according to that, what will be the moment of force depressed by the rule? So for that, I can simply write that moment of force is nothing but the weight multiplied with the distance. Now what is the weight of the meter rule? It is 10 gram force multiplied with, now the distance will be 50 centimeter. So my final answer will be 500 gram force centimeter. Now they are asking us, how can it be made horizontal by applying a least force, which means that the fulcrum or that particular pivot point was over here. So it is by logical sense only that I have to put a weight right over here, otherwise it will just fall off. So in that case, I can write that 500 should be equivalent to the weight multiplied with the distance, which is 100 centimeter. So 500 divided by 100 is equals to the weight. Therefore, the weight is nothing but 5 gram force. So what I can say is that by applying 5 gram force upward at the 100 centimeter mark. Now let us move on to the next question. Now according to the next question, it is given to us that a uniform half meter rule. Now it is not of 100 centimeter from 0 to 100. Now it is from 0 to 50 centimeter. Can be balanced at the 29 centimeter mark when a mass of 20 gram is hung from its one end. They haven't told us from which end. So the first part is draw a diagram for the arrangement. So what I have to do? So for that, I am considering this as my meter rule. Over here, this particular part represents the 0 centimeter and this part represents the 50 centimeter mark. Then they have also told us that it is kept balance at 29 centimeter. That means the fulcrum is at the 29 centimeter mark. Now, the whole weight of this particular half meter rule will lie at its middle, just like the previous one. So for that, the weight of the meter rule will lie at what? 25 centimeter. Okay, I'm considering this as the weight. So according to that, they are asking us like, and they have also told us that 20 gram is hung from its one end. If I suppose that the 20 gram is hung over here, alright, this part represent the 20 gram portion, which is 20 gram force. So according to that, it means that now for this particular part, this is the diagram for my first portion. Then they wanted to ask us the mass of the half meter rule. That means one of the part is this one and another part is this one. So for that, I can simply write for part B, this diagram is for part A, that weight of the meter rule multiplied with the distance, which is 29 minus 25, will be equal to 20 multiplied with 50 minus 29, because all the distances are measured from the pivoted point. Now weight multiplied with 4 is equals to 20 multiplied with 21. So what will be the weight? So it will be 20 multiplied with 21 divided by 4. So this will be 105 gram force. Now after that, they have asked us in which direction would the balancing point shift if 20 gram mass is shifted inside from its one end. It means that they are shifting this 20 gram force in the inside manner. So if this 20 gram force is shifted on the left hand side, that means the distance between the fulcrum or the pivoted point and this particular weight will become less. So to maintain that thing, to maintain that distance, I have to shift this particular point to the left hand side only. Alright. So in that way, I can say that the balancing point should be shifted to the, I can say 25 centimeter, to the 25 centimeter mark to compensate for the mass of 20 gram force which has been shifted. So now let us move on to our next question. Now, in this particular question, it is given to us that a uniform meter rule of mass 100 gram is balanced on the fulcrum at a mark 40 centimeter by suspending an unknown mass m at the mark 20 centimeter. So according to my question, if I say the diagram will look somewhat like this, like if I draw over here, this particular part represent 0 centimeter mark, this represent the 100 centimeter mark. After that, it is kept balanced. First of all, the weight of the meter rule will lie at its center of gravity, which is 100 gram at 50 centimeter, but the fulcrum has been made at 40 centimeter, and they have told us that they have suspended a particular mass m which is unknown to us at 20 centimeter mark. That means over here somewhat. So I can say this is a mass small m at 20 centimeter mark. So now how to solve this particular question? I can simply say that the two kind of motion over here is this and this. So same way we can do is that for part A, the mass m multiplied with the distance. What distance? 40 minus 20 will be equal to the 100 multiplied with 50 minus 40. So this will be m multiplied with 20, which will be 100 multiplied with 10. So m will be simply 100 multiplied with 10 divided by 20. 25 times is 100. So this will be 50 gram. This will be my first part. Then after that, they have asked us to which side the rule will tilt if the mass m is moved to the 10 centimeter mark. So consider in this way. If I have shifted this 20 centimeter mark mass to the 10 centimeter part, the distance will increase. If the distance is increased, you can clearly see over here that since it is 50, now 50 multiplied with 40 minus 10, which is 50 multiplied with 30, is equivalent to 1500 gram force centimeter. On the other hand, this is much more lower than that. That means being it at a greater value, the rule will tilt on the left hand side. So I can say for part B, the rule will tilt on the left hand side. After that, they are asking us what is the resultant moment now. So in that case, for the new case, I have to say that for part C, I can simply say that so the resultant moment will be 50 multiplied with 10, which is 500 gram 4 centimeter. Now it may come to your mind that how we are multiplying it by 10. So they are simply telling us to find out the resultant moment with respect to the previous arrangement. That means the previous arrangement was at 20 centimeter. If I am shifting it to 10 centimeter, so now the distance has been changed only by 10 only. That's why I am multiplying the whole value by 10. After that, they have asked us how can it be balanced by another mass of 50 gram. So for that, I have to consider something like I can say that let a mass of 50 gram be suspended at a distance of x centimeter from fulcrum to the right side to balance the mass of 50 gram at the 10 centimeter mark. So for that same way only 100 multiplied with 50 minus 40, which was as same as for that for the ruler or the meter rule, plus why adding up, because this 50 gram is on the right hand side only, which will be as a part of the meter rule. So I will write 50 multiplied with x is equivalent to what? 50 multiplied with 40 minus 10, because they are taking the new scenario in this particular perspective. So this will be 100 multiplied with 10 plus 50x is equals to 50 into 30. So 1000 plus 50x is equals to 1500. So 50x will be 1500 minus 1000 is 500 only. So x will be 500 by 50, which is nothing but 10. So I can say that for over here, therefore, it will be at 50 centimeter. Now, how come 50 centimeter? Because as I have stated that I am taking this as x centimeter from the fulcrum. So the fulcrum was at 40 centimeter mark. So 40 when added with 10 gives us 50 centimeter. And now let us move on to our last question of this chapter. And this is a bit different type of question. So there is a little less chance for this type of question to comes into your board examination. So the question is, in a figure, a uniform bar of length L meter, that means this whole thing is of L meter, is supported at its end and loaded by weight of W kilogram force at its middle. That means this half is L upon 2 and this half is also L upon 2. So I have to find in equilibrium, find the reactions R1 and R2 at the ends. So there is a simple concept over here that we can say that total upward reaction is equals to downward weight of the bar which is given to us. Now what will be the total upward reaction? The total upward reaction will be R1 plus R2. What will be the downward weight? That will be equivalent to W. Let us consider this as equation 1. After that, if we just focus on these two, I can say that both of them are playing the role to balance this part for it to be in equilibrium. So for it to be in equilibrium, first of all I can say that R1 into how much? The distance from the fulcrum. Over here, nothing as sort of fulcrum is present in this question, but this weight acts as the fulcrum because it is at the middle. So I can write L upon 2 plus R2 into L upon 2 is equal to the total reaction. I can suppose this. So if I can suppose in this manner, so I can directly write therefore R plus R is equals to W. So 2R is equivalent to W. So now I can say that for a single R it is W upon 2. If the whole R is W upon 2, so I can simply say that on adding both of them I was getting R and I was supposing that. So these two are playing the role of this single part. That means these two must be equal to each other. So now therefore R1 will be W upon 2 kgf and R2 will be W upon 2 kgf. So this was our last question of this particular chapter. I hope you did love this video. So do like, comment and share with your friends and family and do subscribe my channel. Thank you.